Yo, what's up everyone? Today we're gonna be discussing equivalent concept and normality. Okay, so first let's begin with a small analogy, okay, to understand what an equivalent is. So imagine this is a glass, okay, you put some lemon, okay, put some lemon juice, just squeeze some lemon. Now there's lemon juice here, and this is sour. Okay, so imagine you add 1 spoon of sugar. Okay, you took a spoon, you added 1 spoon of sugar. So now the taste is balanced. It's balanced. You successfully neutralized the sourness of this orange juice by adding 1 spoon of sugar. So now let's take another example. You took an orange, and now this orange is a super orange. Okay, you added the same amount. Let's say you added 50 ml here, and you added 50 ml here too. Okay, but then when you put 1 spoon of sugar in it, it wasn't balanced yet. Okay, it wasn't neutralized completely, so you put 2 spoons of sugar. Okay, 2 spoons of sugar. Okay, so from these both cases, what is the conclusions that you could make on equivalence? Okay, so from here, the orange, let's say it was, now let's remove the orange. Okay, let's just say you put HCl. Okay, you took a test tube where you put HCl 50 ml. Okay, and you added 1 spoon instead of 1 spoon. We'll just say you add 50 ml of NaOH. Okay, 50 ml of NaOH to completely neutralize it. With this gives you so here the equivalence that reacted was 1. Okay, okay, the equivalence that reacted was 1. So coming back to what we took from the orange, you added 1 orange and you had to put 1 spoon of sugar to neutralize it, right? So the one equalizing job, it's kind of balancing, but let's just see that. Okay, one balancing job performed by you. Okay, just one balancing job is nothing but the equivalence. It's kind of hard to understand at starting, but then I think this analogy will help you understand pretty good. Okay, so now let's look at a few more terms. Okay, first is normality. N. Okay. So now this is nothing but equivalence of solute divided by volume of solution. Okay. So second term, equivalence, which we just saw right now. Okay. That's nothing but weight of solute divided by equivalent weight of solute. Now our last thing, equivalent weight that's molar mass divided by n factor. We'll be coming to n factor in a bit. Okay, so now let's just make a few conclusion about these two formulas, these three formulas. So note this down pretty quick. Okay, so normality was equivalence of solute, which is nothing but this. Okay, and then equivalent weight of solute is here. So just substitute. You will have normality equals weight of solute times n factor upon molar mass times volume. Okay, so from these three formulas, this is the conclusion that we can draw. Okay, so by substituting it, just try it by yourself. And now we can group these. Okay, weight of solute by molar mass, that would be nothing but number of moles, right? That's nothing but number of moles. And this is n factor, will come to that. So we can say normality equals, what's that, number of moles by volume times n factor, which is nothing but molarity times n factor equals normality. Okay, so now let's discuss some questions. Okay, take 1.5 grams of NaOH. Okay, so volume, let's say it's 1 liter. Okay, so to find normality of the solution, okay, we just have to find the number of moles of NaOH. That would be nothing but 1.5 divided by molar mass of NaOH. That would be nothing but 23 plus 16 plus 0.1. Okay, so that's 0, 40. Alright, so that would be number of moles. Now coming to the normality, number of moles divided by volume. Volume was 1 liter. 0.5 by 40 divided by 1 times n factor. Now let's discuss n factor. Okay, by the way, n factor for NaOH is 1, so the normality of the solution will be 1.5 by 40. Okay, it's nothing but so that's like 0.0375. Yeah, so now let's look at what n factor is. So for acids, it's gonna be basicity, or the number of dissociable, or yeah, the number of H protons it can dissociate. Okay, the second one would be basicity, sorry, bases. For bases, it would be its acidity, number of OH minus it can dissociate. For ionic compounds, it's gonna be the charge on cation or ion. Okay, so if you were to take, let's say, Na2SO4, okay, the highest charge on cation or anion, so that would be SO4 2 minus and then 2 Na plus. So this charge, okay, this charge, so basically your n factor equals 2. Now the final one, redox reactions. Okay, talking about redox reaction, it's the number of total electron change, which is basically number of electrons gained slash lost. So if I were to take Fe2 CO3, sorry, C2O4, okay, now that would give you Fe3 plus CO2 plus O2. Okay, so if you want to write down the charge for carbon, that would be, for iron it's plus 2. Okay, 2 times 2, that's 4, plus 2x minus 8 equals 0. That's 2x equals minus 4. Okay, x equals 2. Okay, here it's plus 2 charge, and when you come here you'll arrive at plus 4 charge. Okay, so going from here to here, there's 2 carbon atoms here, 2, but then we're only doing it for 1 carbon atom. Okay, total electron change, that would be 2 electrons, and from plus 2 to plus 3 it's being oxidized. It's being, yeah, it's being oxidized. Okay, so that would be one electron. Okay, so the n factor for this would be 3, right? And now I have a table over here. Okay, make sure to memorize this table. So the example we just took right now, what is it? Okay, let's just start it. Okay, that gives you 42. Okay, so if we were to take another very common example that comes in most of your questions, that would be MnO4. Okay, MnO4 minus, okay, first an acidic, the most important. Okay, then we got basic. Okay, in alkaline medium, and then the neutral medium. Okay, okay, so if we take these, okay, now let's find the charge for MnO4 minus. That would be x minus 8 gives you minus 1, so x would be plus 7. Okay, so when it reaches here, okay, it's giving you Mn2 plus. Okay, Mn2 plus. What be Mn2 plus? That's 2 plus, right? So what's the electron change that occurred? Okay, you're going from plus 7 oxidation state to plus 2 oxidation state. That's reduction. Okay, so got reduced by 5 oxidation states, so that's 5 electron. Okay, 5 electrons, you can see it over here. Okay, and then coming to the next one, it's 531. Look at this series. Okay, so basically acidic, neutral, basic. Okay, A and B 531. Okay, so MnO4 minus, that will be plus 7, and then here we have MnO2, that's nothing but plus 4. Okay, so the electron change that occurred, that was 3 electrons. Okay, so here again plus 7 plus 6, only 1 electron change occurred. Okay, and then this is how you balance redox reactions. You can balance it by yourself. Okay, so most of the questions they would have something like KMnO4 in acidic medium. So instead of calculating it each time, if you just memorize these values, okay, you could just directly say that it's 5 and factor is 5. Okay, KMNO4, K is always plus 1. It belongs to the first group. Okay, and then these metals, they just never change their oxidation state. It's always 1. Okay, so now we talk about questions. Okay, be something like KMNO4 in acidic medium is reacted with Fe. Okay, it's not Fe2. C2O2. Okay, C2O2 2 minus, that gives you Fe3 plus K plus Mn2 plus, then CO2, then O2, right? So it would have something like, let's derive one more formula from here. Okay, from this part, if you were to multiply volume to normality, it would give you number of moles times n factor. If we go back to here, if you multiply volume to normality, you get equivalence of solute. Okay, so this is nothing but your equivalence of solute. Basically the equivalence of the reaction taking place. So coming back to the sugar and orange example, okay, the super orange had a n factor of 2. Okay, 2. Okay, analogous with probably H2SO4, but then don't worry, oranges don't have H2SO4. Okay, so you got your orange juice, you had to add two spoons. Okay, probably the spoon had n factor 1. Okay, you had to add 2 spoons of sugar. Okay, so the equivalence of this reaction, equivalence of products and reactants in this reaction was 2. Okay, so coming back to here, we know the n factor for KMNO4, that would be 5. Okay, for Fe2, FeC2O2, that's nothing but ferrous oxalate. Okay, that's 3. Okay, so let's say you had 5 mole of KMNO4 is reacted with FeC2O2, and both are completely reacted, and then they ask you how many moles of FeC2O2 reacted. So one way to do it is probably you balance the reaction, you write out all the coefficients. That would take a lot of time, right? So if you remember the n factors, okay, n factors for this reaction, what you can do is equivalence of KMNO4 reacting is equals to, okay, is equal to equivalence of FeC2O4 formed. Sorry, that's also reacting. Basically, the law of chemical equivalence says that all equivalents of all substances reacting, equivalents of all substances reacting is the same as equivalents of products being formed. Coming back to here, it would be nothing but this is the n factor respectively, and that's the mole. Okay, so moles of KMnO4 potassium permanganate reacting times n factor of 5 times 5 is nothing but the equivalence of KMnO4 and then equivalence of FeC2O4 ferrous oxalate, that be n factor multiplied by number of moles. That be nothing but 5 times 5 divided by 3. Okay, that's 25 by 3. Okay, this is probably like 8.33. Okay, so there's also another good example, sorry, good definition for equivalence. It goes like 1 equivalent is equal to 1 equivalent weight. Okay, let's say for acid, 1 unit equivalent weight is nothing but a mass that yields 1 mole of H plus ions. This is specifically for acidic, for acids. For bases, it would be OH minus. Same definition but just with OH minus. Okay, so if you were to take H2SO4, okay, and you put it in water, that gives you 2H plus ions, okay, plus SO4 2 minus. Okay, the equivalent weight of this, first let's just say the molar mass of H2SO4, that would be 98 grams. Okay, to yield 1 mole of H plus, okay, that would be 98 grams yields 2 mole of H plus. Okay, so then 49 grams yield 1 mole of H plus. So going back to here, that was nothing but the equivalent weight. So after understanding the analogy, if you were to again do this, molar mass was 98 grams and the n factor was 2, that will give you 49. And that's the same thing we saw right there. Okay, now let's take a question where you probably have to find normality for Let's just take H2SO4. Okay, let's say 7 grams of H2SO4 dissolved in 1 liter of solution. One way to do this would be molarity times n factor. Okay, the molarity would be nothing but 7 divided by 98. Okay, that would be 40. Okay, be 1 by 14 mole divided by 1 liter. Okay, times n factor, which would give you 1 by 14 times 2. It's nothing but 1 by 7. Okay, so if we were to take our analogy method, okay, from here, okay, basically 98 grams yielded you for 2 mole of H plus, so 49 grams yields 1 mole of H plus. That was the equivalent weight. Okay, so now to find equivalence, that would be nothing but 7, that was the weight of solute, divided by equivalence, equivalent weight of the solute, that would be 49 grams, right? This, and from the question we have 7 grams. Okay, so we're gonna get both of them here. Okay, so that would be 49, that would be 1 by 7. Okay, the equivalence reacting from that reaction was 1 by 7. So what is the volume? Normality is nothing but equivalence divided by volume. So that will be 1 by 7 divided by 1. That would give you 1 by 7 equivalence per liter. Okay, that's the unit of normality. Equivalent liter inverse. Okay, so a quick recap from our analogy that we took. Okay, so from the orange analogy we took, equivalent is nothing but one balancing job. That was being done by the sugar. Okay, so if there are two equivalents, you added 2 spoons of sugar, they are both doing 2 balancing job to balance the strong, the super orange. Okay, so yeah, that's it for today's video. Okay, this would be the equivalent weight, that's nothing but molar mass divided by n factor. Okay, so peace out.